Hello everyone, welcome back to the channel. So today I'll be discussing the daily problem of day 16th of this month. So I'm not able to solve the 17th, 19th and 20th day problem because they were hard problems and I was not able to solve them. And I'll be discussing the problem of the 17th day. Not 17th actually, it is 18th. Okay. Yeah, so this is the problem. So after having the quick glance to this problem, I thought that it would be a DSU problem where we have to find the maximum number of nodes in a connected component, but that was not the case. Unfortunately, I've got two wrong answers on this. But after reading the problem carefully, I have found that we have to take a pair out of all possible pair of nodes. We have to take a pair of two nodes and calculate how many roads are going from both of them. Let me make it more clear by taking an example here. Let's suppose out of all possible pairs I have chosen two nodes and the roads are going from one road is connected to this, one edge is connected to this here, and one edge is outgoing from this also here also, and the nodes which I have taken are connected itself also. Now what we have to return is we have to return the number of edges that are outgoing from all the means from both the nodes. Like here one edge is going from here, 2, 3, 4 and 5, and if there is an edge between the taken nodes, we have to count it as one because that node is going from outgoing from this also and this also, so we have to count it as one. Okay, so this will be counted as one and this will be counted as one, because if we count all the outgoing edges from both the nodes, from here we will get 1, 2, 3, and from here we will get 1, 2, 3 and 4. So this will be counted as 4 plus 3, that will be 7, but that is not the case. We have to consider this one as single edge. Okay, so the answer will be 6. So this is all what we have to do in this problem. And now let's move on to the approach, that how can we do this. The approach is quite simple. We have to just simulate the process that I have explained here. Okay, and the value of n is up to 100 only. So what we will do is we will run two for loops to iterate over all possible pairs of nodes, and we will take the value as duty as the degree of this node and degree of the another node that we will take into consideration. And first of all we have to pre-calculate all the degrees of each node in the graph by taking the outgoing edges from that particular node. And after that we will run two for loops to iterate over all possible pairs, and we will take like degree of this node plus degree of this node. Okay, degree of B. And one more thing we have to take care of is let's suppose we have taken these two nodes and these two nodes are connected by itself. Okay, so we have to subtract decrement our answer by 1 in this case, because the degree of this will be the number of outgoing edges from this will be counted as 1, 2, 3 and 4, and from this we will count it as 1, 2. So the this will be considered as 1, so we have to decrement our answer by 1. And iterating over all the pairs we will take the maximum of each. So let me show you my code, my implementation part. So first of all let me show you what I have done here. First of all I have make the disjoint set union, and I have counted the maximum number of connected component in a maximum number of nodes in a connected component, but that was not the case. I have got the wrong answer. Then this is the correct code. Let me show you this. Yeah, so this is the case, this is the code. I have initialized my answer as 0 and I have make a vector or degree where I will pre-calculate all the degrees outgoing edges from each particular node, and I will store that in my degree vector. Okay, and then I have taken two things, set and set of pair of edges. Set of pair of edges I have taken for that condition that we have to check that if this node and this node are connected itself or not. Okay, so now I have iterated over my given graph and I have implemented the degree of that particular two nodes which are connected to each other, and I have inserted that particular edge into my edges set. And after that I have run two for loops for iterating over all possible pair of edges, and if that edges are same then I have continue, and else I have taken the first node as I and second node as j. Okay, and connections, the connections will be how many nodes are outgoing edges from the ith node, and how many edges are outgoing from the jth node. This will be considered as total number of connections from ith and jth node. And then I have checked that if the considered edges are connected itself or not. So if that particular edge is being present in my edges vector, then it means that that particular edge is being connected. So in that condition, I have to decrement my connections by 1, and I'll take the maximum out of all possible pairs of nodes. Okay, and I'll simply return the answer. So this was all about this problem. This was a very simple problem. The tag is though medium, but it is a very simple problem. So go and code this up, and happy coding.